This video is to accompany section 4.2, the mean value theorem, in our calculus textbook. And so I'm going to, maybe this is becoming a familiar exercise, but have you sketch a graph that connects the dots as shown. So there is a number A and a B on the x-axis, and the f of A and f of B are as shown. They're not necessarily at the same height. So I will suggest that you pause so you have time to sketch the graph. Okay, now that you've made your graph, I have a prediction about it. Okay, perhaps I don't know exactly what your graph looks like, but I'm going to suppose that it might look, something like this. And my prediction is at some point the derivative of your graph is equal to f of b minus f of a over b minus a. That's kind of an odd prediction. But if we take a look at the graph here, if we look at this secant line, the slope of this secant line is equal to f of b minus f of a, the change in y over the change in x, which is b minus a, right? And that's exactly the slope, or that's the value of the derivative that I'm predicting that your graph has. If I take a look at this example that I've got and I draw the tangent lines, there are some places where the tangent line, that if I draw it, are parallel to the to the secant line that's there. And because those tangent lines are because those tangent lines are parallel to the secant line, the value of the derivative at this particular c value would be equal to f of b minus f of a over b minus a. So now, of course, you could have gotten around that if you had a function that was not differentiable, and I will let you try to figure out how. But now, again, why does this have to be? If we let g of x be equal to f of x times the quantity f of b minus f of a over b minus a times the quantity x minus a. So f of x minus some number, that f of b minus f of a over b minus a, the slope of the secant line, times the quantity x minus a. If we check the values of the function g of x when we let x equals a, g of a, when we plug it in, we would get, of course, we would have, if we let a be put in for x right here, we would get, this would be a minus a, that part would be 0, and then we would be just left with f of a. On the other hand, if we substitute b in for x, we can imagine what's happening there. The b minus a and the b minus a would cancel here. We would have f of b minus f of b, and we have minus a minus f of a. We would get f of a. So we've met the conditions for Rolle's theorem. And so then the derivative would be equal to f prime of c minus this constant times constant, because we would take the derivative of x minus a, which would be 1. And so if we set that equal to 0, we would say f prime of c is equal to f of b minus f of a over b minus a. This is exactly what, so here's the formal statement of the mean value theorem. If we have a function and all it has to do is be continuous and differentiable on the interval from a to b. So there's no requirement that the two endpoints have to be at the same height in this case. Then at some point the derivative will be the slope of the secant line. Okay, and so here's an exercise to illustrate this theorem. We want to verify that we have for a given function that it satisfies the hypotheses of the mean value theorem on the given interval. And we also want to find all the values of c that satisfy the conclusion of the mean value theorem. Okay, in this case, our function is f of x equals 2x squared minus 3x plus 1. And the interval that we're given is from 0 to 2. Okay, we would have our function is a differentiable and continuous on the interval from 0 to 2 because it's a polynomial. Also, f of 2 minus f of 0 over 2 minus 0 would be, if we just do the arithmetic, here's f of 2, here's f of 0, and 2 minus 0, that's the change in x. Okay, we would get 8 minus 6 plus 1 minus 1. All over 2, so 8 minus 6 is 2 over 2, which is 1. So the slope of the secant line that we would have if we were to draw the picture for this would be 1. We're going to find the derivative And of course, so our function is 2x squared minus 3x, so the derivative plus 1, so the derivative would be 4x minus 3, and we're going to solve the derivative equal to 1. And we're using 1 because that's the value of the slope of the secant line that we found. So 4c minus 3 is equal to 1. That would give us c equals 1. So we found the value of c.